Well, one thing you want to note about Sage is it's another open source project consisting of a bunch of volunteers. And so it can be fussy when you're trying to meld two systems together, of course. If you'll notice on the screen here, I'm actually running off of my server at Mississippi College. I have uploaded these files to the test course. They're not running properly yet, so I'm going to run them off of here so that way I can make sure they work. Running them off my own server here means I can change the Sage cell server to whatever I want to if I have to, easier. All right. If you don't know, Sage is a computer algebra system that's open source, comparable to Mathematica. By the way, I have not converted these to PGMA. I didn't see any reason to just for this. But this is a linear algebra problem. And one of the issues, I guess, with WeBWorK is that the graphing capabilities are pretty minimal. And so a while ago, Paul was showing you one way. This way, using Sage, I could use all of Sage's graphing capabilities. And so the major reason for me using this was Sage had a 3D graphing utility that was pretty nice, which they have since broken. And so I'm not going to show you any of those. But here's a 2D one. So here's a linear algebra question talking about solving a linear system as a linear combination of its columns. So that's described here. And so what I've done is create column 1 is A1, column 2 is A2, and just stuck them end to end. So that's essentially 1A1 plus 1A2, and that obviously doesn't equal B. And so one of the nice things about Sage is it'll draw you a nice picture, but it has this ability to interact with it. And so I can change the values of x1 and x2 dynamically. One of the things I like about this as well is the student can't run to Wolfram Alpha and get the answer immediately by typing in the question. So if I look at this, it appears that I might need to let A2 be negative. The coefficient is negative. And so I'll just make it a little more negative. And I've drawn the original here in gray. Looks like A1 needs to be a little longer, so I'll make the coefficient bigger. And you can see I can interact with the graph here until I can finally show that B is in the span of A1 and A2. All the graphs here are managed by Sage. Did I get it? Let's just zoom in then. Well, they can if they want to, but they don't get the answer, but they don't have the input data. They don't know what the numbers are here. If I make it sufficiently random. You might be able to try to guess them from the picture. And so you'll notice here that I've landed by taking 3/2 of the first column and then minus 17/10 of the second column. And that does seem to give it to me. And so let me submit the answer. Woohoo! Got it right. And just for the fun of it, I do also get a new version of this problem, but I've set it up so that you get a new version of the problem only after you get it correct. So they have to solve their given problem first. That's just my way of doing it. And so you see it's a different problem. The 3D version I'm not going to show you, but that's a lot of fun here because trying to get those things to line up in 3 dimensions is a lot more fun. Here's another problem where it's typical for a linear algebra course when you're trying to do rotations and various reflections and expansions and contractions. And it says at the top to choose the correct linear transformations in the correct order so that the blue-green pentagon is transferred to the red one. So I'm trying to make this pentagon over here into this red one. And so the first thing I think I'm going to do is reflect across the y-axis. So that's the blue with this matrix transformation at the bottom down here applied to it. And then the next thing I want to do is what? Let's skew to the right. So I'm skewing it. That looks good. And then finally it looks like I need to do an expansion vertically. So a vertical expansion, bam, woo! And so it turns out that Sage is doing all this graphing for me, and it's also doing all this matrix calculation down here in exact arithmetic. And so here's my final transformation that would transform the blue to the red. And so all this kind of stuff is when you want to have some exact arithmetic and you don't want to deal with the matrices perhaps in Sage. So this gives us a computer algebra system, a way to expand WeBWorK with a kind of a computer algebra system. This is a place where Paul's Wronskian example earlier, we had to go through and type all the 3x3 matrix manually. You could probably handle that in just one fell swoop with Sage by going out to that. I'm just looking at the the code for this. First, there is a macro, sage.pl, which takes some of the div things that Paul was showing you earlier and wraps them all up into the macro so you don't have to see them. But it's essentially the same kind of thing that Paul was showing you. I'm using begin text, end text just because I am. One thing to note again, if you haven't caught this yet, is you can put a bunch of these kind of begin PGML, MPGML, begin text, end text all through the document. And so in this one I have several. This appears above the Sage code. This part right here is a string we're starting. I guess the Sage code, not a string, but the Sage code is going to be after this. I'm going to store all of this Python code here into this variable until I get down to this. So that's the bottom. Everything inside here is Python. And so the spacing matters a lot now. You'll notice that I'm sending in regular Perl variables into this Python. I don't have to go through and save them as regular Python variables. It's just easier not to keep on typing the dollar signs. I'm sending an answer out. So this x1 and x2 are essentially what I'm dynamically determining when I move those sliders for the vectors coefficients, sending those back out to the Perl side of things. A couple other things to show you. In Python, in Sage, the @ symbol is reserved for creating what they call an interact. So this is a special thing that you have to have for Sage to create these interactive features. Unfortunately, @ means something to Perl. And so therefore we put these two tildes in front of it to escape that out so that it knows to interpret this as an @ for the Python side, not to interpret it as an array for Perl. The other thing to note, if I can find one here, I guess I didn't do any LaTeX in here, but in Python, in Sage, they use dollar signs at each end of a LaTeX expression to, say, format it for me, and then I have to convert all those. So if you're used to using Sage, you have to use quote, open and close to start and end formatted math. Okay, so I have essentially Sage code trapped between these two things. And then I call Sage. And so this is the way we call Sage with the Sage code. There's several modifiers you can put here, what do you want the button to say, whether you want the cell to automatically evaluate, or do you want to say quick evaluate. I got a little more text down here just because I wanted to say something below it. And then there's this named answer. You've seen that once before, I believe. And this is how we're going to check to see whether whatever answer comes out of Sage matches what we want to check with in the WeBWorK side. So we are going from a randomization. We go back up. All this randomization up here is done the normal Perl way. That's in this little Perl bottle. It doesn't Anybody that might have the ability to spelunk around in Sage won't have access to this. That information is then passed here into the Python side of things, manipulated, used, and all the things you might want to do with this, including multiplying the matrices together and all done inside here. And then we check the answer down here. Just to show you, I'll show you the wiki page in just a second. But you can get a lot of different kinds of things that aren't interactive. For example, if I want a really nice graph, I can just ask Sage to do it. And so this is me asking Sage to just draw me some nice implicit graphs. So that would be another option that you could do if you're just trying to draw a graph. One last thing about Sage is here's an option where I'm trying to do polynomial interpolation. I give them a bunch of points here. I've actually drawn this using WeBWorK because I wanted it to be like this. This is a regular WeBWorK kind of matrix that we can go through and type in pieces here. I don't want to do it all. But, you know, 1, -1, you know how to do this. But I also have a cell right here where the student can go in and actually directly edit inside the Sage portion. And so if you were actually doing this, I've actually entered the first 2 rows are entered here correctly for interpolation. That would be, what, 81 here. And I'll make a change on one more of these, I guess. It doesn't matter. And I can evaluate that cell. And so you can kind of mix and match these things. And waiting. And notice I've asked it to go through and take this matrix and put it in echelon form using rational numbers. And so you can interpret this result down here. The student should be able to recognize there is no solution for what I entered, which is not correct. But they could actually get the answer from this last column. And if I've done it right, let's see. I'm hoping these are the right ones. I don't remember them all. Oh, well. But they can get the answers here from the Sage portion. Okay. There it is. If you do WeBWorK wiki and look for Sage embedding, it will describe all of this. And so you use the Sage macro. If you're trying to check answers that WeBWorK has created, you create an answer list. And so you check lists of things. So in this particular problem here, I'm checking to see whether this is the answer you get out. I create some Sage code. And so here I'm trying to integrate this function for variable x from 0 to pi. And that is probably this value right here. I then record the answer. This is the way you actually send an answer from the Sage code back to the WeBWorK code. This is the calling routine that says do it. And then here is where you check your answer. It actually prints the Sage code wherever I did the calling up here. That's how it prints it. There are a bunch of flags you can change. And so you can see those here. Answer return. If you don't have an answer, if the Sage code is just drawing you a picture or just doing something for you and you're not trying to send something back to the WeBWorK side, you set that to 0. Again, WeBWorK, to get to this page, Sage embedding. And I'll bring you right back to here. This macro should be included in the distribution now. So there are several of these stored in the test courses. So you can look at those and browse through them. It should be near the bottom under Sage embedding. So you can see several of them here and get to the code there if you want to. Okay. The next thing is draggable proofs. I'm using this in our junior level intro to proofs course, or what we call foundations here. And this is the in-between step between just doing basic propositional logic and having students write their own proofs. And this is where you give them a list of statements of some sort, and you ask them to put them in the right order. And so we can drag these around if I can get it right. And I don't know what the correct ones are here, but you can see how this might work. Formatting obviously does appear to be working. And we can submit some answers, and it shouldn't be right unless I just got really unlucky. And just for the fun of it, so I don't have to do any thinking. So we'll assume that's the first one, so I guess I don't need that one anymore. There exists a K, must be second, so we'll try that one. B plus C equals boom, so that one. So that must be the next one. And you can fuss at me about whether this is correct or not. But this should be a proof, ordering 5 of those, of the original statement that A divides B and A divides C implies A divides B plus C. And of course, you can do hints if you want to. I didn't forget it. And so there you go. You can check those. Oh, this is actually on test courses. Okay. There are numbers of these. Let me see if I can find what I'm looking for here. Well, this is one dealing with limits. You'll notice I have some wrong statements. This is one dealing with set containment. Let me just show you one of these. Probably not a it has too much stuff in it. So let me go. I can find a nicer one. There we go. So this is order 8 of the following sentences, so they form a logical sequence of subsets. And so the empty set would go first. And then, I don't know, I guess the real numbers is probably going to use somewhere. The integers will go somewhere. The rationals will go somewhere. I hope we're getting these right. The complex ones will go somewhere. That's 5 of them. All right, I've got the integers here, so 0 must not be included, other than natural numbers. And for me, that's the wrong while ago. The natural numbers don't include 0 in my world. So 1 maybe goes there. 1, 2, 3, 4, 5, 6, 7. What are we missing here? Help. I don't know. Show correct answers. All right, and submit them. Oh, there's a 0 there. That's a mistake. I have the empty set right here.
No, that one's correct because n is a subset of that, and it's a subset of the integer.
Oh! I knew that. I was just kidding. All right, there we go.
And Lorraine got it, so she gets points.
All right. This is what happens when you're presenting something, right? The obvious is not obvious. But anyway, that's how it goes. Just look at the code for this one. This was one of those times when if you can find David Cervone and get him off by himself, he's pretty awesome. He's pretty awesome all the time, but this is one. There's a thing called draggable proof, this macro. There's also one called draggable list where David was trying to go through and make it much more general for lots of possible reasons. We have not released this yet into the world yet, so you have to grab this from the course, macros, and it's there if you want it. But it's pretty simple. You call draggable proof, which I'm calling it correct proof. You put a bunch of strings here, formatted or not, inside a list, starting with this bracket, ending with that one, comma, and then next a list of all the ones that you are trying to throw in to bother people. So these are the false ones. These are the ones you don't need. The order in which these are is the order in which they have to be. There's no other option right now. You can get 2 options. So again, the ones you want in order, and then all the distractors here. Whatever you want to put at the top of the source, the ones you pick from, whatever you want to put at the top where you're putting them. You call that list of lists, I guess, And I can pull up the number needed so it knows how many I'm looking for. You can print out all of them here, including the box, including the draggable area, and you can then check down below using correct proof comp. This is all documented on the wiki. Do WeBWorK and search draggable proofs, and we'll put, of course, this in here. And of course, this is the correct proof. If you want to order these in increasing usefulness, Jason Aubrey's, and then someone better than Jason but less than everyone else, and then, of course, me. I stuck one more thing out here that I think is kind of interesting you might want to know about. It's called Student Course Assessment. And I don't know if I remember seeing this, but sometimes you want people to always get something correct. You don't want to count up at all. You just want them to read the problem and prove they read the problem by clicking yes. And a typical example of this might be if you're doing a course assessment. And so at the end of the semester, you might want to steal this. I use this in my courses all the time. The WeBWorK system was very friendly, somewhat friendly, etc. WeBWorK system was fast. Level of difficulty was compared to other classes. I thought the online homework was useful, was not useful, the time I spent. Your typical kind of questions, and then you can do essay questions. Just as a little reminder of how this might look. All standard stuff up here, and the only difference is, well, this is an essay question, so sorry, rats. Actually, that gets enter an essay. Previous, there we go. And so there's this answer auto-write. So this is using your standard answer checkers, not the PG ones. And I guess you could put this inside the asterisk. But auto-write is one of the options, and whatever you put inside here is whatever it tells you whenever you enter whatever you want. So you can actually have people or whatever they want to have students, whatever they enter is correct, regardless of what it is. So that's just something you might find useful.